locations which store data. Pointers store where the data lives in memory. Let's learn pointers in C programming. Watch the video till the end for lots of examples to understand the concept better. So what are pointers and why they matter? Pointer is a variable that stores the address of another variable and it allows direct memory access. It's essential for working with arrays, strings, functions, and for allocating memory dynamically. And pointer concept is a key to writing efficient and flexible C programs if understood well, and if it is mishandled, it might cause your system to crash. The unary operators ampersand and the asterisk. The general syntax of declaring a pointer is data type, asterisk, and the pointer name. Thereafter, we will initialize the pointer with the address of an already declared variable. The unary operator ampersand gives you the address of a already declared variable, and the unary operator asterisk, which is a dereferencing operator, lets you access the value that is stored in a particular address. That is shown with the example here. So x is a variable declared and assigned with the value 100. P is a pointer that is declared and assigned with the address of x. Thereafter, the value 100 can be printed either using the normal variable x or using the pointer, using the syntax asterisk of the pointer, that is dereferencing the pointer. How pointers store memory address? Variables are stored in RAM at a particular specific location, and pointers store these memory locations. So supposing I have a location that's assigned with a value 100 and it is given a name A, and there is a pointer P that points to that memory location. For understanding sake, let's assume this location is in a hexadecimal address location that's shown here. So the pointer variable will store that address, and the pointer that points to the address contains the data 100. The pointer size depends on the system architecture. Let's see this with an example. So here I have three variables, x, y, z, which are normal variables of type integer, char, and float, and correspondingly I have three pointers of those respective types. Now I am trying to look at the size of all these variables when I run the code. So you will notice for integer, char, and float, depending on your system configuration, the bytes have been shown, but the pointer size is the same irrespective of what type of pointer it is, because pointers point to memory locations and store addresses. So the size of the pointer variable, irrespective of what data type you declared it to be, will be the same. In this code snippet, to show you the use of the unary operators ampersand and the asterisk, a normal variable has been declared and assigned with the value 100. The pointer variable P has been declared and assigned with the address of x. And thereafter, if I try to show using the format specifier %dx, I'll get the value, and the correct format specifier to retrieve the address will be a %p, and that will show me the address. So when I run the code, the data is obtained and the address is shown as a hexadecimal value. Either I could have used a p or I could have shown the address of x. When you perform pointer arithmetic, namely the increment decrement operations, the pointer moves by the data type size. An array name acts like a pointer because array name stores the base address of the contiguous memory locations. A pointer stores the address of a variable, so we can understand the array name to be treated as a pointer. Functions can modify values using pointers. Let's look at this with an example. A typical example to show the use of pointers in functions. We have done this normal swap code here. So the actual arguments a and b are taken by the formal parameters x and y, and internally they are swapped. So after the function call, displaying the changed values of a and b, we'll get to see a and b continues to have the original values and not the swapped values, because we know that the actual arguments are passed by value. When passed by value happens, changes made to the formal argument will not be reflected in the actual argument. So alternative way will be to have the we'll have another function which now works with pointers. So I'm having two pointers shown in my header as formal parameters, and I could have a temp to take the content of x. The content of x is overwritten with content of y, and content of y is written with the element value in temp. Now correspondingly in my call I'll have these two statements done again. So in my call I'm going to have the address of A and address of B passed. Or if you do not want the addresses passed, then here itself we could have had two pointers declared. So a P1 that takes the address of A, and a pointer P2 which takes the address of B, which only will require in the call the two pointers to be passed. So the first swap did not swap the actual arguments, but the call to the second function has swapped the actual argument values. So when you pass by pointers, it is basically passing by reference, and changes made to the formal parameters will reflect in the actual arguments. To understand pointer arithmetic, I have a string declared and initialized. Assume I have a pointer declared of type char, so I'll call it as a CPTR and assign it with the base address. So array name itself is the address of the contiguous memory locations. So when you're assigning the address, we're not supposed to use the ampersand. It will directly be the array name itself. Now I can run a loop because the initialization has happened. I can skip the initialization part as long as content of that pointer is not a null, and increment the pointer every time. So this is going to jump by the data type size pointing to the subsequent locations. And maybe in this code I'm trying to change the given string to uppercase, so I can have the content of CPTR change to upper of content of CPTR. So coming out, when I try to print the change string through the original variable, it should show the string in the changed case, like that. To look at one example with structures and pointers, I have a structure defined, a data type sample defined. I'll declare a variable of type sample, a normal variable and a pointer variable. The pointer variable will be initialized with the address of S1. And assume for the normal variable we'll give some initial values also, like that. And trying to display the details, if it's using the normal variable with the format specifier, I'll say S1 dot A, and with the pointer variable the member selection operator is the arrow S2 dot B. When I run the code, the value through the normal variable and the value through the pointer variable has been shown. Now with the pointer variable, how to use the member selection operator dot? In that case we'll have content of, because the left side of the member selection operator dot should be a normal variable. So we'll try to derefer the pointer variable like this, but in this case it's important that you have this parenthesis for changing the order of priority, because the member selection operator will have a higher priority. So excluding the parenthesis will throw an error, because the dot operator on a pointer variable is not allowed. So we're going to dereference the pointer and then try and obtain the contents. Another interesting concept is function pointers. Just like a pointer holds the address of a variable, a function pointer holds the address of a function definition, and this helps you to improve the flexibility and efficiency of a code because it allows you to dynamically call a function at runtime. So a snippet has been shown here. There are two user-defined functions to perform arithmetical operations, addition and subtraction, and a function pointer has been declared like this. Depending on the choice, the function pointer is made to point to the appropriate function, and then there's just one call statement that's needed. So depending on the choice, the function, which function is to be called, is determined at runtime. So dynamic function calls is possible through function pointer. So when I run the code, depending on the choice, supposing I enter a 1, the addition is performed. Common mistakes related to pointers: uninitialized pointers. So declaring a pointer, not initializing it with a valid address, dereferencing a null pointer. So trying to retrieve the content of a pointer which is not actually pointing to a location which contains data, using the wrong format specifier. So if you have a integer variable, the pointer pointing to that location should also be of type integer. So the variable data type and the data type of the pointer should be the same. And accessing memory out of bounds. These are the common mistakes, and the corresponding solutions will be: always use a initialized pointer, at least initialize it to null, and before trying to retrieve the contents using the dereferencing operator, check for null, whether the pointer is holding some data and not just null. The format specifier has to be appropriately used, and the dynamically allocated memory has to be freed within the scope of the variable. Let's look at this with an example. To look at how memory can be dynamically allocated at runtime, I'll use a syntax which makes use of the malloc function, and I'll represent the number of bytes that I want. So just now let's assume I'm going to store an integer value. Now the malloc function will take memory from the heap memory at runtime and return the address of the memory that's been dynamically allocated, which is stored in the pointer variable p. Now to use malloc, we'll be requiring the standard library.h, and after the memory has been allocated dynamically, I can initialize it with some values statically or read value at runtime, and I can work with that content. And after the operations on the memory has been done, it's so important to deallocate the memory. For a normal variable, once the scope of the variable is over, the memory that is statically allocated will be released. But for a dynamically allocated memory, which is done using the malloc, we have to explicitly free the memory using the syntax free and the pointer name. So I'm running the code. The memory has been dynamically allocated. To the memory, a value has been assigned and the value has been displayed, after which the memory has been released. But after you've released the memory, it is wrong to have any reference made to the pointer because it's now not available in memory. More codes on pointers have been listed here, and the solutions for this are available in my GitHub repository, whose link is as shown below. It's also shared in the description. Do have a look. Do like, share and subscribe. Happy coding!